Hello students, I'm coming to you with the next video lecture which will cover Rubin and Babi chapter 11. So let's go ahead and get started. So first off, we are finally finished with unit number 3 and are now moving on to unit 4, which will cover designs for evaluating programs in practice. We will talk about a variety of research designs within this unit, but we will begin our discussion by talking about causal inference and experimental research designs. So here's our diagram that we've been looking at all semester long, and as you can see, we are now moving down to the third phase in the social work research process, which is related to choosing a research design and data collection methods. Before we get into the specifics of experimental research designs, I'd like to start by laying some groundwork and just providing some definitions and key concepts that will be useful as we move forward in our discussion of research designs more generally, as well as experimental designs specifically. So the first thing I'd like you to understand is the difference between group and individual research designs. So single case or single system designs are more geared toward individual clients, whereas experimental and quasi-experimental designs are more geared towards groups of clients. And still, program evaluation design is geared towards or can be geared towards either individual clients or groups of clients. So as you will see when we get to chapter 14, where we talk about program evaluation, this is our most flexible research design. And then finally, survey research can be geared toward individual clients. So now I'd like to talk a little bit about the relationship between research design, inference, and conclusions. Specifically, there is indeed a connection between how we design our research studies and the types of inferences we can logically make and the conclusions we can reasonably draw. So essentially, our research designs or the designs that we employ in the research process are directly tied to the inferences and conclusions that we can draw. So now let's look at the concepts of research design, inference, and causal inference. So in terms of research design, I like to think of research designs as a blueprint that contains all of the decisions made in planning and conducting research, including decisions about measurement, sampling, and how we go about collecting our data. In terms of this idea of inference, an inference is a conclusion derived from a research design that seeks to investigate and draw conclusions about the correlation between an independent and dependent variable. But where in inference, just a basic correlational inference stops short is that it does not allow for implying causation. So by contrast, a causal inference is a conclusion derived from a research design that seeks to investigate and draw conclusions about whether an independent variable has a causal impact on a dependent variable, implying causation. So here is a diagram that helps to look at this relationship between research design and inference. So here on the left-hand side, you can see that in terms of basic correlational inferences, there are two designs in which these kinds of inferences can be made. Program evaluation research, as well as survey design research, particularly survey designs that are cross-sectional in nature. When we're only collecting data at one point in time, this kind of design does not allow for making causal inferences for obvious reasons, right? Only because really it has to do with the fact that when we're employing a cross-sectional research design, we're only collecting one data point. And so there's no way for us to really determine which variable, what caused what, or what the correct ordering of variables are. So within cross-sectional designs, these kinds of designs only allow for basic correlational inferences. On the right-hand side here, we see that experimental research designs allow for drawing causal inferences, as well as quasi-experimental designs single case designs, and then here again, program evaluation design. And then when we get down here to survey research, we see that the only kind of survey research design that allows for drawing causal inferences is longitudinal research, simply because it allows us to collect data on several data points across time. So here are a couple of visual examples that help to solidify these points a bit more. So essentially, when it comes to inferences and correlational research, the reason why we're unable to make causal inferences is because of the fact that, let's just say and take, for example, here, the relationship between substance use and depression. So if we wanted to examine this relationship, we could indeed look at the correlation between these two variables, but we can't really say whether substance abuse or substance use comes before depression or whether depression comes before substance use. Simply because if we only observe these variables at one point in time, we have no sense of the correct ordering of these variables in time. And so this is the reason why we say that correlation does not equal causation. Simply because we can say that the two variables are correlated, but we cannot say that one caused the other. Versus in experimental research, in these kinds of designs, we are typically looking to examine the effectiveness of an intervention or the impact of an intervention on a particular outcome. And so in these designs, causality can be inferred. And the reason for this is because these kinds of designs involve exposure to an intervention where the researcher manipulates or controls the experimental conditions in a way that allows for making causal inferences. And as we move forward in this discussion, I'll provide some examples of why this is the case and what this whole idea of control means within experimental research. So here again, as I just mentioned, when we study the relationship between substance use and depression over time, we are able to collect multiple data points in such a way that it allows us to establish the time ordering of variables. So if we study the same relationship across time, then it allows us to determine what comes first. Is it that substance abuse comes first or depression comes first, right? So if we're able to observe this over time, then we really can get a sense of what comes before what, which is like, and we call this the time ordering of variables or the time sequence of variables. And so the time sequencing or ordering is one of the key criteria for making causal inferences. We have to be able to say what comes before what in time. Okay, and so longitudinal research allows for that, which is the reason why it in turn allows for making causal inferences. So now let's talk about this concept of experiment and experimental research designs. So essentially, an experiment is a method of observation in which the independent variable or intervention is manipulated to determine its causal effect on the dependent variable or a client outcome. So our idea of an independent variable in experimental research is a bit different than non-experimental research. So within experimental research, when we use the term independent variable, what we're really talking about is the intervention itself. And when we use the term dependent variable, what we're talking about is the client client outcome that we are seeking to change as a result of exposure to the intervention. In terms of laboratory experiments, these are experiments that are conducted in an artificial setting in such a way that selected elements of the natural environment are simulated and features of the investigation are controlled. And so laboratory experiments are typically done within medical settings as well as within animal research. But for us as social work practitioners and doing this work within agency context, typically our setting is more of a natural setting, which means that we are more likely to conduct what we call field experiments. And these are experiments that, again, are conducted in natural settings as people go about their everyday lives. So the term experimental stimulus, in an experimental research study, the experimental stimulus is the independent variable or the intervention itself. which is manipulated by the researcher to assess its effect on the dependent variable or client outcome. The experimental group in an experimental design is the group that is actually exposed to the experimental stimulus or intervention. So these two terms can be used interchangeably: experimental stimulus or intervention. The control group is a group of research subjects who receive no exposure to the experimental stimulus. And there is a caveat to this idea of no exposure, because within social work research, we don't literally mean absolutely no exposure, simply because withholding treatment from anyone would be considered unethical. So what we really mean when we say no exposure for the control group is that this group may be exposed to treatment as usual or some other similar type of treatment that is not exactly the same as the experimental stimulus. So here's our case study, and I'm not going to read through it, but I'm just putting it before you once again so that you know and understand that we're continuing to draw on this scenario even within our discussion of experimental research designs. So here's our conceptual framework, and as you know, these are the 6 variables that we, or 5 variables that we were looking at over the past few lectures. And so we were looking at, or looking to see the extent to which these 5 variables predict this outcome of parenting self-efficacy. So let's just say that we've collected our data and we now have our study findings. And let's just say that we found that depression and social support are the 2 strongest predictors of parenting self-efficacy among non-resident fathers. In addition, let's just say that the 2 most significant predictors of parenting self-efficacy for mothers is depression and anxiety. So just keep that in mind as we move forward in our discussion. So the basic logic of experimental research designs. So this is our classic experimental research design. This is the most basic research design that you will find, and most commonly utilized design that you'll find in experimental studies. So essentially what is happening here in this diagram and what underlies the basic logic of experimental research designs is that here this X is our intervention or experimental stimulus, okay? So essentially what happens as the researcher is that we randomly assign our clients to either the intervention group or the control group, okay? And again, randomization or random assignment is very important, and I'll explain the reason for that momentarily. But we typically randomly assign our clients to either group. And then let's just say that our intervention is individual therapy, and our outcome of interest that we're trying to change is depression, okay? So what we would do, or essentially what would happen, is that we would measure depression prior to exposure to the intervention. We would expose our intervention group to the intervention or experimental stimulus, and then we would measure depression once again post the intervention. We would also measure depression prior to the intervention among our control group. So we would take our pre-test measures at the same time from both groups. We would also take our post-test measure from our control group as well at the same time that we do our intervention group. So essentially what we would be looking to see, or what we would hope to happen, is that as a result of exposure to the intervention, which is in this case individual therapy, we would hope to see decreases in depression over time from pre-test to post-test, particularly among our intervention group, given that they're the ones that have been exposed to the experimental stimulus. So here are the steps just written out in words for the classic experimental research design. So in step 1, we would randomly assign subjects to the experimental group or control group. We would administer the pre-test to all subjects in both groups. And then we would administer the intervention under investigation to the experimental group only. We would administer the post-test to all subjects in both groups. And then finally, as I just mentioned in our final step, we would assess the amount of change in the dependent variable from pre-test to post-test for each group separately, hoping that we would see the change that we would expect in our client outcomes, depending on the intervention that we are administering. And then I would even add a second step to this, which oftentimes doesn't happen in intervention studies. But if I were to add a step 6 to this, I would say follow up, right? So we don't want to just stop at measuring outcomes at one point in time with our clients. We might want to follow up with them perhaps 6 months or 12 months after exposure to the intervention to see if the intervention is still taking effect, if they're doing better, if they're doing worse, how are they doing 6 or 12 months down the line post exposure to the intervention. So the strength of experimental research design, one major strength in experimental designs is that they allow for making inferences about causality. And the ability to make these inferences really has to do with the element of control. This is what makes drawing causal inferences possible in experimental research designs. In experiments, the investigator has control over three things: determining who participates in the study, what happens to them, and under what conditions. So here's a diagram here that helps to see this whole idea of control in experiments visually. So essentially, the researcher would select their sample and they would randomly assign clients to the experimental condition or the control condition. And so the ability of the researcher to control who goes into what group, when individuals are exposed to the intervention, and such is what allows for control to happen within these experiments. And because of this level of control, it allows the researcher to draw inferences about causality. So let's look at this idea of causality a little further, because there are some common criteria for inferring causality that we need to be aware of. There are certain conditions under which we can make these causal inferences, and we have to be sure that we at minimum meet these three criteria in order to be able to make any causal inferences. So the first criteria is time sequence, the second is correlation, and the third is alternative explanations. So first, time sequence. The first requirement in a causal relationship between two variables is that the cause precede the effect in time. The time order that connects two variables must be clear. So essentially, the researcher can control timing of exposure to the intervention. This is one thing that the researcher can control. They can control, again, when the intervention comes into play, when participants are exposed to intervention, to the intervention, the timing in which that happens, who is exposed to what. There's a great deal of control that the researcher has. Okay, and because of that control, they can sort of meet this criteria of time sequence. The independent variable in this particular case will always come first in time before the dependent variable because the researcher can make it so, right? So the IV or the intervention, participants will always be exposed to the IV first, in this case, the intervention or the experimental stimulus. In time in the experimental research designs because the researcher is able to manipulate the timing, okay? So it's like playing chess. The researcher is in control of every move, including time sequence or timing of exposure. Correlation. The second requirement in a causal relationship is that the two variables be strongly correlated with one another, okay? So essentially, we have to be able to say that if the intervention, then the outcome, okay? So if there's no intervention, then there's no outcome. So in other words, the intervention and the outcome must be related. There must be a connection. Going back to the example that I just gave, the connection between individual therapy and depression. We have to be able to show statistically that there is a correlation between individual therapy and depression, that these two variables are correlated. That's another requirement for establishing causality. And then finally, alternative explanations. So the third requirement for a causal relationship is that the observed empirical correlation between two variables cannot be explained away as the result of the influence of some third variable. So we call these third variables threats to internal validity. And so we're going to talk about several different threats to internal validity coming up soon here. But essentially, these threats to internal validity are other variables that come into play that influence the correlation between the intervention and the outcome. Okay, so these are other explanations. These are other things that get in the way of establishing the fact that that the intervention was indeed effective in influencing whatever the outcome is that we're trying to impact. There are three additional criteria for inferring causality that are mentioned in your text, and they are strength of correlation, plausibility and coherence, and consistency and replication. I only really want you to know the three main criteria that we just discussed, but I still wanted to put these here just so that you are aware that there are other criteria as well that are not as often discussed or cited in the literature. These are other criteria that sort of came along later on down the line. These are sort of new discoveries in the literature, but the three that we just discussed are the ones that you will continuously see over and over and over again in the literature. So I really want you to be most aware about those three. So now let's talk about common threats to internal validity. So essentially, alternative validity refers to the confidence we have that one variable is the cause of another. So in other words, the intervention is the cause of client outcomes. One thing to keep in mind is that we always want to be able to say, ideally, that the intervention is what caused the outcome, not some other factor, some other extraneous variable or confounding variable that came into play over the course of the implementation or administration of the intervention. We want to be able to say that we want to be able to rule out all other variables and be able to say that it was indeed the intervention that caused the outcome. That's ultimately what we want to be able to say as a researcher. However, we have to be aware of these threats to internal validity, because having an awareness about them gives us the ability to control for them and to minimize them as much as possible. How we go about designing our studies allows us to control for certain threats. And so we'll talk about that later on in this lecture. But these threats to internal validity are what we would call alternative explanations for the outcome of an experiment. So here are the 5 most common threats to internal validity: maturation, history, testing, experimentation change, and selection bias. So here's an analogy that I usually like to give my students as we talk about threats to internal validity. It's almost like a balloon. It's almost like your intervention in this experiment that you're conducting lives inside of this balloon or inside of this bubble. But you have all of these threats that are coming at this balloon in an attempt to try to deflate it, right? And so these are the things that we need to be concerned about as researchers, all of these various threats that come to deflate our experiment. So the first threat is history. So history is changes that occur as a result of extraneous events affecting client outcomes on the dependent variable. This can be any extraneous event that coincides in time with exposure to the intervention. Okay, so these are any events that could take place, any major events that could take place over the course of time that our intervention is taking place. This is most likely to be a threat when the intervention takes place over a long period of time. So if our intervention happens to be more longitudinal in nature, then that's when we have to be more concerned about this threat of history. So let's just say, or take for example, that during an intervention with non-resident fathers, a citywide strike occurs, leading to losses in jobs, closures of childcare facilities, and a host of other businesses. So is it the intervention or the event that affected client outcomes on the dependent variable? Okay, so this is the question that we have to ask when it comes to history, especially again when when our intervention is occurring over a long period of time. If it's a major event that impacts the client population that is included in our intervention, then we have to be concerned about whether it's the event, is whether it's the intervention or the event that affected the outcomes of the study. Then we also have maturation. So maturation are changes that occur as a result of the passage of time affecting client outcomes on the dependent variable. So these are shifts that can occur due to developmental changes or the passage of time. Okay, so we can have short-term impacts, which may be changes in behavior or attitudes, or long-term impacts such as aging or becoming more educated, or etc. So let's just say that we're designing an intervention program that takes place over a 2-year time span. So within this time frame, let's just say that both the father and his children grow older and become more educated. So is it the intervention, or is it the basic developmental changes that have taken place within the father and the child over time that cause changes in the outcome? Okay, so this is maturation. This is just the natural passage of time that happens. And again, this is particularly a threat when we have interventions that occur over long periods of time. Then we have the threat of testing. Okay, so these are changes that occur or do not occur as a result of pre-test sensitization affecting client outcomes on the dependent variable. So this is exposure to the pre-test. This idea of the threat of testing has to do with exposure to the pre-test and how that can impact performance on the post-test. So let's just say in our intervention, we do the following. We collect pre-test data, we administer the intervention, and then we collect post-test data using the same measurement tools. So the question becomes, is it the intervention or is it exposure to the pre-test that affected client outcomes? Could it be that clients have simply remembered their responses to the pre-test and repeated those same responses in the post-test? Okay, so that's one thing that we have to worry about with regard to testing. Anytime our design utilizes a pre-test of some sort, we always have to be concerned with this threat of testing and whether clients are responding or giving similar responses on both the pre-test and the post-test. So in terms of the threat of instrumentation change, these are changes that occur as a result of switching outcome measures from pre-test to post-test, affecting client outcomes on the dependent variable. So let's say that we collect data on levels of depression using the Beck Depression Inventory at the pre-test. We administer the intervention, and then we collect post-test data using an entirely different instrument, such as the Center for Epidemiological Studies Depression Scale. So then the question becomes, are these two measures equivalent? Yes, they both measure depression, but are they equivalent measures? How do we determine if change occurred from the pre-test to post-test when two different measures of depression were used? So ideally, and I can't really think of a logical reason for doing something like this, but ideally we always want to use the same measurement tool. Well, actually, now that I think of it, the only example that I could think of that would justify this, or not necessarily justify it, but the only example I could think of where this could potentially happen may be with folks that just really don't know what they're doing, right? And they really don't understand the importance of utilizing the same measurement tool throughout the intervention from pre-test to post-test. It's very important for measurement equivalency that we use the same measure each time. Otherwise, we run into this threat of instrumentation change. So selection bias. So this is another threat that we have to be concerned about. So these are changes that occur as a result of non-equivalent groups affecting client outcomes on the dependent variable. So let's just say, for example, that we put half of the non-resident fathers in the experimental group and the other half in the control group, but we fail to randomly place them in each group and instead allow them to choose which group they will be in. So then the question becomes, is it the intervention that caused the change in the outcomes, or can the results of the study be explained by differences in the characteristics between groups? So ideally, we always want to try to achieve group equivalency. We always want the characteristics between the control group and the experimental group to be equal. Um, and so we want them to be very similar in terms of their characteristics. Otherwise, it's very unclear whether it's the characteristics, the differences in characteristics that cause the change in outcome, or the intervention itself. Okay, so when we have non-equivalent groups, then we run into this issue of selection bias. So let's look at this idea of group equivalency a little further. So group equivalency, when making comparisons between experimental and control groups to determine the effect of the IV on the DV, it is important that the two groups are equivalent or composed of people who are as much alike as possible. Okay, so we want the characteristics between our experimental group and our control group to be as identical as possible for us. There are two methods that your text discusses with regard to ways that we can go about achieving group equivalency. The two methods are matching and random assignment. So matching. The first approach of achieving equivalency involves matching. Individuals in the experimental group with similar, sorry, let me go back and restate that. The first approach to achieving equivalency involves matching individuals in the experimental group with similar subjects in the control group. People are matched on the basis of variables that are presumed to have an effect on the outcome of the intervention. One of the things that you can do is you can look to the literature to determine which variables people should be matched on. Okay, so by matching, we make the experimental and control groups equivalent on these variables so that they cannot account for any differences between the two groups on the dependent variable. So we can look at the literature and see what others have done in terms of what characteristics they have matched their participants on, and do the best that we can to match our participants on as many variables as possible. And typically we match them on their demographic characteristics specifically. So things like age, socioeconomic status, marital status, anything that we think will influence the outcome of the intervention, we should consider matching our clients on. So this is essentially how we would go about it. This is a visual here. So we have the individuals in our experimental group and we have the individuals in our control group here. And so we try to match them as much as possible on their respective demographic characteristics. However, this whole process of matching is not perfect by any means. So there are so many variables that might be needed for matching that it becomes impractical to consider more than a few at a time. The researcher needs to know in advance which factors might affect the dependent variable so that these can be included in the matching process. Okay, so though imperfect, matching is better than no attempt to control at all. Okay, so there are so many variables that we can match our clients on, and there's no real way of knowing exactly whether we have accounted for all potential variables that we should. Like I said, we can go to the literature and at least educate ourselves and become aware of some of those demographic characteristics that we need to be matching on, and that's really the best that we can do in terms of trying to make our groups equivalent through this process of matching. And then we have randomization. So this is the second approach to achieving equivalency. So random assignment uses chance to reduce variation between experimental and control groups. The point is to make sure that each person has an equal chance of being placed in either the experimental or the control group. This approach offers the greatest probability that the experimental and control groups will have no systematic differences between them. So if we randomly, the idea is if we randomly place our clients in the experimental and the control group, that their characteristics will become evenly distributed, okay? through this process of randomization, which is all, as I said, based on chance. Okay, so we just kind of assume that if we randomly assign, that the characteristics will be evenly distributed throughout. Okay, so everyone has an equal chance of going into either group. And this also helps to reduce bias, right? So we don't want to get ourselves in the position where we're placing only certain clients in the experimental group and other clients in the control group, because there can be a lot of controversy around experiments, because sometimes folks think that, you know, oh, they got placed in the experimental group, they're getting something better, right? When we really don't know that it's better, because we haven't tested its effectiveness. We don't know whether it works or not. We're testing it. That's the whole point of an experiment, right? But yet and still, there can be a lot of politics around who gets placed in what group. So the process of randomization can also help to reduce these biases and issues that come about in the selection process. In theory, when using the randomization method, the differences in the DV can more confidently be attributed to the effect of the IV, because there are no biases in group assignment. So essentially, that's what I just discussed. So assignment to an experimental or control condition is equally likely by chance, as I just mentioned, and it is assumed that through randomization, the characteristics will be evenly distributed across experimental and control conditions, leading to equivalent groups. So here is another visual here where we have all of our clients here in our pool, and we are randomly distributing them to either experimental or to either the experimental or control condition. However, yet and still, there are also problems with randomization. Okay, so even though in the long run, randomization can yield equivalent groups, this approach is still can still generate non-equivalent groups on occasion, especially when the study sample is small. Okay, so the larger the sample size, the more likely it is that there will be greater variation in group characteristics. So the larger our sample size is, the more variation we will have across groups. So additional threats to validity of experimental findings. So here are some additional threats that are discussed in your text, and I'm not going to go through these in detail, but I do want to put them here just so that you are aware that there are some additional threats beyond the five that I just mentioned. And they include measurement bias, researcher reactivity, diffusion or imitation of treatment, compensatory equalization, compensatory rivalry or resentful demoralization, and attrition or experimental mortality. So now let's look at this idea of external validity. Okay, so we've talked about internal validity. Now let's talk about external validity. So when a study has a high degree of internal validity, it allows for causal inferences to be made only about the population and setting that were studied. Okay, so those findings are only specific to that setting and that population. A high degree of external validity allows for generalizing the findings of a study to settings and populations that go beyond that given study's condition. So when a study has external validity, it means that the findings not only apply to that particular setting or that particular study, but can be extended beyond the conditions of that study. Even when internal validity is high, external validity can still be low, and vice versa. Some factors that influence external validity are representativeness of the study sample, the setting in which the intervention was delivered, and study procedures employed by the researchers. Okay, so this is one of the things that you want to think about as you review studies, intervention studies, and think about how they might apply to your own practice. It's very important that you take into consideration the setting in which the intervention was delivered, because if the setting looks very different than your own, then it might not be feasible for you to carry out in your own setting, or it might not be very useful for you in your own practice. So this is something to think about as well, as not only the validity that is internal to the actual experiment itself, but also to what extent those findings can be generalized. So now let's look at the 5 different types of experimental research designs that are discussed in your text. So first, we've already looked at this. First is the classic experimental design. This is the most common design, and it is also referred to as the pre-test, post-test control group design. This design attempts to control for history, maturation, selection bias, and instrumentation changes, okay, assuming that measures remain the same from pretest to post-test. So as long as those measures remain the same, then this particular design does control for instrumentation changes. But if that instrument changes, then we have a problem. Okay, so then that becomes a threat if for some reason the instrument that we're using to measure outcomes changes for some reason. Otherwise, if it doesn't change, then we're okay. However, it does not control for testing. Okay, this is one design that does not control for testing. And the reason for that is because there's a pre-test and a post-test. So remember that the threat of testing has to do with exposure to the pretest, right? And this idea that if clients are exposed to the pretest, then they will somehow remember their responses to the pretest and give similar responses on the post-test. Okay, so this design is great and it controls for every other threat with the exception of testing. So here's our intervention, and I've come up with this, and this is the classic experimental design, but I still want to draw on the example or the case scenario that we have been discussing throughout the last few lectures. So the intervention that I've come up with, I'm calling Keys to Competence in Parenting. Okay, so let's just say here that for our experimental or intervention group, that we are conducting an intervention, specifically individual therapy and mentoring. Okay, and so we want to look at, because going back to what I mentioned before when I talked about our findings for non-resident fathers, remember that I said the 2 factors that most predicted parenting self-efficacy for them was depression and perceived social support. Okay, or just social support, but I'm calling it perceived social support in our model because most of the measures out there are really not just about social support, but about perceived social support specifically. So I changed the title of the name of the variable slightly, but we're still talking about social support. So anyway, so let's just say here that we're administering this intervention here, and we want to measure at the pretest. This should say pretest here. At the pretest, we want to measure parenting self-efficacy, depression, and perceived social support. Okay, among our intervention group, and we also want to measure the same thing among our control group. Okay, we administer our intervention to our intervention group here, and then we measure the same outcomes using the same tools at the post-test for our intervention group as well as our control group. Okay. The next design is what we call the post-test only control group design. So given the issue with pre-tests, we can opt for using a post-test only control group design. Another reason for choosing this design may be that in your practice, it may not always be feasible to conduct a pretest with your clients. Maybe you don't see them often enough, or you have a client that's very transient, right? And so you can only get post-test data from them. You may not be able to collect both pre and post. So that might be another reason why, other than the issue of, or other than the threat of testing. So this design controls for history, maturation, testing, and selection bias. Okay, so it controls for all of these things. And then the issue of instrumentation changes doesn't apply to this particular design simply because there's no pretest, right? So, because there is no pretest, we don't have to necessarily worry about our instrument changing from pretest to post-test, if that makes sense. Okay, so there's no pretest here. Okay, so we don't need to worry about any instrumentation changes here, assuming that we're only measuring outcomes one time, right? And we're measuring it with our experimental group and as well as our control group. And we're using one measurement tool. Okay, so we're not worried about any changes in instrument from pre-test to post-test. And then our next design is the Solomon 4 group design. And this is a very fancy, sophisticated kind of experimental design here where if we want to measure the change in client outcomes from pre-test to post-test, but we're concerned with testing effects, then we can opt for the use of the Solomon 4 group design. So if we see here, if we draw a line right down the middle here of this design, we can see that it is a combination of the pre-test, the classic experimental design or the pre-test post-test control group design, as well as the post-test only design. So it's taking the two designs that we just discussed and putting them together into one design. Okay, so that's essentially the Solomon 4 group design. It combines both because let's just say that perhaps we want to do a pretest or we need to do a pretest for some reason. We can still do the pretest, but we can also do a phase of the intervention where we do no pretest. Okay, so we're combining both and we're addressing the effects of testing while also collecting pretest data just in the event that we need this data for some reason. Okay, and it also lets us see if there is, this design also allows us to see if testing is really an issue, right? Because if we're comparing the intervention and control group here and we're looking to see whether pre-testing was an issue with these two groups, then we can compare that to these two groups to determine whether testing really was a threat, okay? So we can see both at the same time. This design attempts to control for all five threats to internal validity: history, maturation, testing, instrumentation change, and selection bias, okay? And the reason why it controls for selection bias, all experimental designs control for selection bias in the sense that randomization is used, okay? So anytime that we talk about experimental research designs, by nature, experimental research designs utilize the idea or the method of randomization. So that's what this R means here, right? So this R in the diagram means randomization. Okay, so that's the reason why this particular design and all other research designs control for selection bias. Now, when we talk about quasi-experimental designs do not use randomization. They typically use matching, okay? And we'll talk about the reason for that. But inherent in an experimental research design is the use of this method of randomization in order to achieve group equivalency. Okay, so just keep that in mind as well with regard to experimental design specifically. So the alternative treatment design with pretest, okay? So some experiments are designed to compare the effectiveness of two alternative treatments. So this is the I and the C in our PICO question, okay? So we've been talking a lot about how in some studies, some studies only look at the effectiveness of one intervention and other studies look at the effectiveness of one intervention in comparison to another. So this kind of design allows for looking at comparison or comparing two interventions to each other. So this design, again, is called the alternative treatment design with pretest. Pretests are recommended in such experiments so that the comparative amounts of change produced by each treatment can be assessed. So even though we know that testing is an issue or can be a threat, in this kind of design, it's actually recommended simply so that we can see the amount of change that occurred from time 1 to time 2 so that we're able to compare amounts of change across each type of intervention. This design attempts to control for history, maturation, instrumentation changes, and selection bias. The one thing that it doesn't control for is testing because of all of the pre-tests here. Okay, so this is the one threat that it does not control for. And then finally, we have our dismantling study. So a similar type of design can also determine which components of the intervention may be most effective in achieving certain outcomes. So this design controls for history, maturation, experimentation changes, and selection bias. Again, it does not control for testing because of all of the pretests here. So essentially this design, what it does is it looks at, let's just say that, going back to our example, right? So we're looking at, in our intervention that we've designed for non-resident fathers, we're looking at both individual therapy and mentoring, and how these two modalities influence parenting self-efficacy, social support, and depression. Okay, so remember, going back to our example of keys to competent parenting. So the specific intervention program that I designed based on our case scenario that we have been looking at over the past few lectures. So let's just take that as an example. We can look at essentially what a dismantling study would allow us to do is to look at both of these treatment modalities, so intervention and mentoring combined. And then what we could also do is look at just individual therapy alone and just mentoring alone. Okay, so it allows us to really tease apart these two treatment modalities to see which ones are most effective, which ones are most necessary, which of the components of the intervention are most effective or necessary in achieving the kind of outcome that we're desiring. Okay, because it could be that perhaps individual therapy is most effective and maybe mentoring is not so effective. Okay, so designing our study in this way would allow us to really break apart the components of our intervention and really look to see which component is the most effective one in achieving our outcome. So here's on the next slide, there's a table that I've put together to help you to kind of remember all of the various different threats to internal validity and which ones are associated with which type of experimental design. And so in the following table, if you see a plus sign, this means that the threat to validity is controlled for. If it's a minus, it indicates a weakness in this design concerning the threat to validity. A question mark indicates that it could potentially be a possible threat, and a blank space indicates that the threat is likely not relevant to that particular design. So here is the table. Okay, so I won't go through this or read through this, but you can utilize this in your own time of study to help you to sort of bring together all of these concepts and understand which threats are associated with which type of test, or sorry, which type of design, excuse me. So a brief note on providing services to clients and control groups. So I alluded to this earlier, but I will go back and reiterate this again. Within social work agency context, it is often unacceptable to withhold services to control groups, as doing so would raise many ethical concerns. Thus, withholding, when we say withholding, we simply mean that the control group does not receive the experimental intervention that is being tested during the period of study. Control group clients are likely to receive treatment as usual or an intervention that is similar but not the same as the one being tested. Okay, so you'll see this more than likely a lot in your intervention studies, that they will use this term as this term called treatment as usual. And essentially that just means routine services. Whatever services they were already receiving, they will continue to receive. They may also, so individuals or clients that are placed in the control group may also be placed on a waiting list to receive the experimental intervention once it has been tested. And so we call this a waitlist design, where individuals are placed on a wait list, and once the intervention has undergone its complete trial of testing, then whomever is on the wait list will then be offered an opportunity to take part in the intervention. So in terms of critiquing experimental research designs, I've put together a couple of tables for you that include each of the threats to internal validity as well as critique questions. that you can think about or ask with regard to each threat. So these are the threats that we went through just now a minute ago here. And then I've added on some additional ones that are also included in your text. So the first five here are the ones that we just discussed: selection bias, testing, instrumentation, history, and maturation. But then these are also some additional considerations in terms of threats. So fidelity to the intervention, attrition, measurement bias, researcher reactivity, diffusion or imitation to treatment, diffusion or imitation of treatment, and compensatory equalization, compensatory rivalry, or resentful demoralization. So as you write up your article critique too, these are some of the things that you'll want to keep in mind as it relates to critiquing your respective research studies. And there's an in-depth explanation provided for each of these within your text. So I kept these questions specific to those threats that are covered in your text so that if you need to go back and reference those things, you can. So that is all I have, and I hope that this has been helpful and in terms of helping you to crystallize your understanding of these very complex concepts that are discussed in your text. And as normal, here is my contact information if you should need to reach out to me for any reason. And I look forward to seeing you in the next class.